My name is Michael Walker. I'm a grad student at Vanderbilt University. I work at ISIS. We'll get to that later. That's not a joke. You'll see. First of all, let's just talk about how I think education and hacking go hand in hand, especially when you get into the computer science fields. Because if you want to do good academic research, it's basically hacking where you take notes. That's really all it is. So if you have hacking skills already, then you can easily transition into education. Or if you don't have any hacking skills and you're looking to get into education, it's a good place to learn a lot of skills if that's what you're looking to do. So here's some basic profile of my resume before I started undergraduate. So I was fortunate enough to be at a high school back in the late 90s that had programming. We had a full year of Pascal, half a year of C++, and if you took it early enough, half a year of VB. Then I taught programming to literally 8-year-olds at Camp Fitch Computer Camp, which is the second oldest computer camp in the country, started in '82, so been around a while. It's held at on Camp Fitch, which is a 450-acre camp on Lake Erie, near Erie, PA. So the programming camp is just a subsection of the full camp, and so campers come for a week, they study and whatnot. And so for two-hour sessions a day, we teach programming. So I had to learn the material that I was teaching as a junior, rising senior in high school, teaching these new kids Logo. Who's here even familiar with Logo? Okay, so you move a turtle around the screen and it draws pictures, and it's really good for teaching functions and logical concepts and ordering of instructions and things like that for young kids. Then I also worked retail, and I did on and off for years doing concert lighting for special events. So that'll come here in a minute. So at my undergraduate, we are the Penguins, one of only, I think, 3 schools in the country. So I got my bachelor's of science in computer science and with a math minor. Good grades, mainly. If I got mediocre grades, pretty good grades, I guess, like 3.5-ish maybe in high school, I found college just unbelievably easier, just because I found it more interesting. Some people have difficulty at college or with education, like rigorous education. My recommendation is then go 3/4 time. Don't go quote unquote full time, and you'll spread out it might take an extra year, but I think you can focus in on the courses you're taking, and you can actually do better in each individual course. So when I went, I took 12 hours a semester instead of 16, which is what you're supposed to take. Technically, 12 hours is still full time. So I went full time for like 5.5 years, but I was only taking 3 or 4 courses, and I was able to focus in on those courses much better than if I was taking 5 or 6 courses at a time and still working. So the reason I'm bringing up the college is because of what, in addition, I did when I was at undergraduate. So if a penguin mascot isn't good enough for you, I bring you official picture from YSU. May the penguin force be with you. So when I was an undergraduate, I did a lot of things. So members of honor societies, student organizations, things like that. And so who here has gone or is going to college? Just by show of hands, okay? Who is going to college? Okay. So I have a fair amount of experience in online education right now, actually, also, and so I think that being able to be on campus, I think, is one of the best benefits of what you would consider traditional college, because it enables you to interact with other people, especially in your major, that you can like free flow of ideas and just general discussions about topics and whatnot. And so that's what actually led to a lot of the work that I did, and actually semi-indirectly led to me going for my PhD. So this START research group, acronym is Students and Teachers Accomplishing Research Together. But what it was is basically a bunch of students that were good in our computer science courses were gathered by a teacher, and she got some grant money, and she said, here's some money, let's do some research, I'll buy the equipment. We just volunteered our time, and then we were able to go to conferences, submit papers, things like that. So we got to play with, I don't want to say play, but we got to play with nice toys, and then do some experiments. So one group, we had an Xbox 360, and so they did a bunch of network traffic analysis to see, was the traffic, can you actually inspect the traffic? So they were able to prove, no, it's actually well encrypted. So especially at an undergraduate level, research that's actually publishable is not actually as difficult or as high of a bar than you would think traditionally, because the expectations aren't as high for an undergraduate research. So, like I said, I did a bunch of things. So I was a lab assistant, and that led me to being the research associate, where we were in the START group. And so one of the other things is, if you're on campus, you can talk to local people on the campus, professors, faculty, things like that. And so this is a very unique thing to my undergraduate, so it's a Cisco Regional Academy. And I was able to put on my CV that I was a technician at the Cisco Regional Academy. I installed Linux and put an FTP and a web server up. That was all I did. So, but it helped build my resume. So that's important. So you can do these odd little jobs that we might not consider very difficult, but to a lot of people are fairly, would be time intensive or things like that. So let's first talk about spelling aside, as I see the typo now, but let's first talk about hacking in undergraduate research. So, like I said, I was hanging out on campus a lot just because of my course schedule. I had a bunch of class time, or time for classes, and then I would go to work afterwards. And so I was helping tutor people, not for money, just teaching different stuff, like networking, that I already knew that I purposely didn't take networking classes. I wanted to get away from that because that was my day job and whatever. But I was just helping people. And so that would get the attention of teachers, and it did. And so the traditional question mark, profit. And the question mark, unfortunately, in undergraduate is you have to put in extra work. So you have to put in a little bit of time to volunteer, to do some work for a professor for free. Whether you're at, let's say, Ohio State, or you're at a small school, that's pretty much what it boils down to. You got to show some effort that you're willing to work beyond what a normal undergraduate will do, and that will lead to profit. And what that profit will be is one of two things. First of all, you'll get a better letter of recommendation. Letters of recommendation out of college are one of your biggest starting off points for getting your first internship, jobs, things like that. The second point is depending on what you do, you might start being able to build a CV, so resume. You can start building your resume either for academic or for getting a job. So like I said, I built the web server with an FTP, and hey, look, I can now put on legitimately, I worked for a Cisco Regional Academy, whatever. So one of the other topics to bring up is the amount of funding that's available right now for this type of research. So who is familiar with the NSF, National Science Foundation? Just show of hands. who's heard of it but doesn't really know necessarily what it is. Okay, that's better. So, National Science Foundation is a part of the federal government that does basic research. So it's doing research into fundamental concepts. So the first NSF REU that I did, so NSF, National Science Foundation, REU is Research Experience for Undergraduates. The first year I worked at UC Berkeley for the summer. So I got a full ride trip out to UC Berkeley, put up, room and board, was able to take a 4-hour class of individual research with a mentor, did research, was able to publish a poster and a paper, get those submitted, things like that. Now, what I worked on was, who here is familiar with Spybot, the idea, the tool for Windows? Okay, so who here is familiar with T-Timer? It's a little side part of Spybot. Okay, T-Timer is or was, I don't know if it still exists, but it was a tool to notify you when your registry changes in your, or changes to your registry have occurred while you're running or installing programs, things like that. Basically what we did, me and a partner, we wrote or rewrote a implementation of a software driver for Windows that did something similar to that. So we wrote an application that could intercept all registry accesses by all applications in Windows. You could then, on the fly, or beforehand have rules, but then on the fly, intercept those registry accesses or changes and alter them. So if an application is asking, well, what's your unique computer ID? Well, you can just randomly generate one and give it, here's what I am. And so that's, who here thinks that's close to hacking, or that's close to, that's not really networking, but it's more software development in terms of hacking. So there's a lot of money at the federal level that goes towards basic academic research for what we would consider hacking, talks that could just as easily be going on at DEF CON versus the IEEE. It's just where are they looking to talk about the material and who's paying for it. So the next summer I worked at Vanderbilt University. I was lucky enough to get into another NSF REU at Vanderbilt University, which is close to here in Nashville. That summer I was tasked onto a middleware group. So middleware, if you're not familiar, is a software framework that assists you in being able to deploy software across either multiple devices or multiple uses and things like that. So it depends on how you're using it. But in our case, it was for, I was tasked with, see if we can write a middleware for Android. I don't know Android. Well, learn it. Okay. And so I spent the summer learning Android. This was right when 2.0 or 2.1 came out. And so I bought Rita Meyer's book on professional Android development. I went down, I basically spent the summer and I learned basic Android. And I was able to then do a bunch of benchmarking utilities. Can Android do encryption? Okay. Can it do this type of encryption? Can it do RSA? Can it do AES? Can it, worst case, can it do DES, triple DES? I mean, just go down the list, see what encryptions Diffie-Hellman, what type of protocols it supports by natively, and what are available. So I was able to, within the 2 months of working on it, be able to write an application that would tell you, these are the encryption protocols that are on the device, here's how fast they run, here's the numerical statistical analysis of 1,000 or 10,000 runs of each one of the algorithms and how fast they took. So that way you could profile the device to see, am I going to be able to, on the fly, use encryption on this device and not incur additional latency in the network? And so that isn't in and of itself a super large amount of what we would consider hacking or research or whatever, but as an undergraduate, that's a fair amount, that's a lot of work 2 months. I put a lot of work into that. So first learning Android, then learning Java too, because I really didn't know it well at that time. And so you can take these small segments of workload and apply them, and you'd be surprised. You can actually accomplish a lot from a resume or CV is just the curriculum vitae, or however you pronounce it, Latin for a longer resume for academics. You can put a lot on your CV or your resume that you wouldn't think that is important otherwise. And so just how many people look at how frequently other people commit stuff to GitHub? I mean, that's a big, hiring managers want to see that you're involved in the community, things like that. And so being able to put these items on your resume is important, because even if after just having these two experiences, I could then go to industry and be like, well, I wrote a benchmarking suite for Android, I wrote a utility for Windows, I did this, I did that. And so that would have given me a much better leg up on the hiring process right out of college versus somebody who's, yeah, here's my class project, if at most that. So the amount of funding out there for computer science, especially if you're interested in computer science, that's involved in networking, security, privacy, all of the topics that you would generally see at any type of HackerCon. If you're interested in those, there's money out there for research, and it doesn't have to be academics that fulfill it. You just have to comply with the academic standards. So if you don't necessarily know to look for these funds, you might miss out on them. But there's lots of grants. Local companies here in Nashville get grant money all the time for what I would consider basic research that a lot of us would just consider hacking these things together. So putting devices on buses and seeing if you reroute the bus routes, can you improve traffic flow? And things like that, that some parts of them are really like mathematically intensive, like algorithms of, can you fix this? But if you don't know that part, get help from somebody else on that specific part. But if you're really good with radio antennas or whatever the case may be, and you're good with hardware hacking, then you can do the sub part of it. So that's important. So now to get to ISIS, which is an interesting name now, unfortunately. So I work at ISIS. The ISIS I work at is the Institute for Software Integrated Systems. It's been around since the 90s. We didn't have the naming issue then. So it's a research institute that's a part of Vanderbilt University. So what a research institute is, and especially ISIS, is that, well, what a research institute can be, let me put it that way, is a subdivision of the university that's working on specific goals. So in a more biology sense, you might call it a lab, where a professor has money, they set up a lab, they do research in certain parts of biology. We have very similar concepts here when it comes to cyber physical systems. So if you're not familiar with that term, CPS, it means basically the exact same thing as Internet of Things, just an older term. So model integrated computing. These are some of the research topics I pulled off of the website that we're working on right now. Model integrated computing, pretty simple, is can I build a model? It's a mathematical model, yes, but building the model itself isn't that much mathematics, but using these modeling tools, can you predict and describe how a system works? The better you can do that, there's mathematical proofs behind that allow you to skip a lot of potential woes further down the evolution of your product. So, smart cities. Everybody's probably heard that term, smart city. Well, okay, what does that mean? Nobody knows. We honestly, we have no idea. We have this concept of there's free Wi-Fi everywhere, great. And there's IoT devices everywhere, great. But what does that actually mean? So does each IoT device have a static encryption key on it? Well, yeah, actually, unfortunately, that's where we're at. So there's a fair amount of webcams that unfortunately had no security on them. How do you mitigate attacks? What is privacy? Do we care about privacy? Do you have privacy? So these are concepts that are very important to hackers, hacker concepts that are also becoming more and more important in academia and have been for a long time, but are gaining more widespread acceptance that they're important. So distributed object computing, how to explain this simply? Botnets, basically. But botnets that actually work for good things. So distributed computing, mesh networks, things like that that don't do bad things, basically, it's the simplest way. Network embedded systems, basically the same. Another term for cyber physical systems. How do you communicate between devices? What type of communication? So obviously when you have in your car, you have a computer that's running your fuel injection, great. You also have a computer in your radio that's turning the dials and all that, great. You have one that's doing your heating and cooling, great. You also now have one for your brakes, okay, great. Which signal is more important? Well, obviously, not your radio. So that's how network embedded systems is. How do you check for errors in the embedded systems networking? And so there's a lot of these basic fundamental research papers that have existed for 20, 30 years that now that the technology has reached the point to where we can actually implement them is more important on a daily physical level. So yeah, I'll get to the picture in a minute. But, education technology, so that's where I'm focusing on, and I'll get that more in a bit. Modeling analysis of complex systems. So that's if you're good with math. That's if you like abstract concepts, modeling. So even if you're not good with math, the tools nowadays and the math that you use is not the math that people think of. So it's mostly set theory and things along that nature that most of the people that I've encountered in these type of conventions are fairly good at, actually. I have this group A, I have this group B, how much do they overlap? So that type of math versus how good are you at memorizing this integral formula. That, I hate calculus. 2 of my 4 Bs in undergraduate. And let me tell you, I fought hard for those. I didn't earn them. I'm pretty sure my professors were just like, you made the math tutors cry. Just take your B and go home. So that's the research institute I work for. And so here's some ISIS propaganda. You can go home and say you saw ISIS propaganda. No. Black humor. So this is, a couple of years ago, they made a nice PDF. I think this was literally a month before ISIS got the terrorist group name became popular. I'll have to check on that, but yeah, timing. So research projects that we're working on range from power systems to high-speed trails to medical devices. So who here is familiar with MRIs? Okay, so you have an idea of what the MRI is. And even if you don't, you know that it takes a scanner of the human body. Okay, so MRI uses strong signals, basically, and it shoots them into your body and reads how they scatter back. Okay, so somebody did some research and said, well, we could actually not use as strong a signal. We can use 1/100th of the signal and use 20 quick fires of it, and then take the images and basically combine them into a better image. And so what that produced was, not at ISIS, but just in general, produced a better image that reduced the overall exposure to the human body from the MRI, or whatever. I think it was MRI. I'm not personally all that familiar with MRI myself. I'm not medical. So trains and things like that, working on safety, modeling of the engines and things like that for better safety, more reliability, just a far-ranging amounts of things that go on at our institute. It's a multi-million-dollar research institute. You're welcome to look it up. There's these types of institutes all over at different research universities. If you find something you're really interested in, let's say you're interested in image processing, or you're interested in GPS, or you're interested in near field communication, not just NFC, but short range radio. You're interested in I don't know, algorithms. You can find these different research institutes to work at. And you don't have to be an academic to apply to work at these locations. You just have to have these skills. So some, like ISIS, are more focused towards industry, whereas others are more focused towards purely academic stuff. So you just find what you're interested in, and you can narrow it down and find a place that you might be interested in working for or reading material from. So, like I mentioned earlier briefly, one second, I am interested in education, and in particular, education at scale, so learning at scale. And so I've been assisting my research advisor on some of his previous MOOCs. And if you're not familiar with MOOCs, they're massively open online courses. We love acronyms. These are 4-letter acronyms. Almost always they're 3-letter acronyms, or TLAs, because, yeah. Doug is one of the experts on pattern-oriented software architecture, and so that was what his first MOOCs were on. And so the first MOOC is concurrent and network software. And the second one is services. For handheld systems. I believe both of these were taught on Android. Because if you're not all that familiar, Android is just a Linux system. It has some special frameworks on top of it, but basically it's still Java running on Linux. But some nicer security frameworks added that on top of it than any other in my opinion, any other currently popular operating system. So that is why you've seen segments of Android propagate out to other operating systems, like services. Services didn't exist in iOS until like a couple of years ago. They finally allowed, hey, maybe a background process would be useful. Wow, yeah. I think content providers are working their way into both, or they were when Microsoft was still trying to make mobile OSs. I have no idea what they're doing anymore. But I think an equivalent of content providers are making their way to iOS at some point in the future, or were being discussed. And so content providers are a mechanism for sharing files within the apps. And so that's not super important. But you'll see these segments of core framework logic being adopted by other operating systems. And so I assisted Doug with making some assignments and things like that with those courses. And so that's led to a new specialization that Coursera is offering right now. It's called Android App Development. And so it has these 5 courses: Java for Android, Android App Components, Intents, Activities, Broadcast Receivers, and another one is Services, File Storage, and Content Providers, fourth course is engineering maintainable Android apps, and then the fifth is the capstone. Fourth and fifth one are, I think the last three actually names are going to vary, but it's a series of courses that, when taken together, will teach you a bunch of topics. And so my main drive on these has been for creating the assignments and assisting with teaching the tools needed for development. So I made a module, which is what they call a section, sort of, on Git. Okay, well, learn Git. I made another one on, I think, Android Studio. And so you just learn these materials, or Gradle, and you just learn the tools on how to actually use these, develop in these environments. But, so who here has ever taken an online course? Okay. Who here would be potentially interested in taking an online course? Let me ask that. Okay, fewer hands and completely separate group. I'm assuming you didn't have great experiences with your online courses. Okay, may I ask why? Go ahead, just speak up. Somebody, raise your hand. That's why these mints are here. If you answer, I'll reward you by throwing these to you. If you don't answer, I'll punish you by throwing these at you. I deal with undergraduates. This is how you have to do it. So you raise your hand.
I didn't really have a bad experience with it. It's just I would prefer to be in a classroom setting just so I could bounce ideas off the teacher.
Okay.
My online wasn't too bad. We had a chat room and we talked and stuff. So
Okay.
It wasn't horrible.
How frequently did they do the chat stuff? Or was the room just open all the time?
Yeah, it was open all the time.
Okay. Because we do virtual office hours where we do Google Hangout sessions, and so people can ask questions. Did you take an online course?
Yeah, I took some, and the biggest thing that I had was the material and not having someone there to kind of show you and guide you.
Okay.
When you need it, but I mean, like I said, they do some teachers do set up office time, but I don't know about bigger universities how it is. I'm at a smaller school, so
So did you take the course, was it an online course?
Yeah, it was.
Or was it a course from your university that happened to be online? So was it through like edX or Coursera, or was it just an online course through your university?
online course for the university.
Okay.
But,
So there's a dramatic difference in how you have to focus. There's a wide range of education research that goes into how to produce a good online course and how to produce a good interactive course. And there are two branches that only meet in the center for a little bit of engagement, but otherwise they're just, from what I've seen, just separate. Anybody else?
In my opinion, I've taken both online courses and through the school. Through the school, they're not that, user friendly. It takes you a long time to figure out where is what. And the online classes, honestly, it was on me. I didn't put enough effort to it just to complete it. And some of them, after a while, it changes, what you were expecting from the course. That you're not that excited about that part of it, so you're just.
Okay. Anybody else? Okay. I was just curious because I'm still crafting segments and stuff, so I'm still trying to wrap everybody's opinions and experiences into making better material. So that's one of the things that they teach is that you shouldn't, smaller segments, so 6 to 8 minute videos instead of hour and a half segments, course lectures basically, so that you can watch a little video, take a break, maybe rewatch it, come back to it, rewatch it, whatever the case may be, or pick up this one when you have time, go to the next one, things like that. So there's an entirely different cadence and structure to the courses online, or should be, let me rephrase that. There should be a different cadence to a course online versus a course in person. So did anybody has anybody taken one of those like boot camps where you work for like weeks, like 8 weeks or something. Have you? What was your opinion on that?
It was all right. It wasn't an online boot camp though.
Oh no, I'm assuming it would be in person at that.
It was a week long for certified ethical hacker.
Okay, so it was. So I tend to not count those as boot camps, at least not in the modern connotative definition of the term boot camp, because the boot camp concept is less like 6 to 16 week, pay like 10 to 30 grand for like learn how to pair program.
It certainly was not this.
Okay. I think the smaller, shorter mini boot camps like that, I think have a higher potential for benefit, because you can focus in on one small, minute area. Whereas instead of some, they're like, we'll teach you to program from scratch, and then you can get a job in Silicon Valley. I don't think that's, even in 16 weeks, I don't think that's, and that actually, I don't even think I think most of them are like 8 weeks. I don't think most people can learn programming in 8 weeks and be ready for deployment in a Silicon Valley type scenario. Mind you, I have a personal bias because I like algorithms, and I can tell you what a Van Endeboss tree is, and nobody knows what that is. If you're lucky enough to know what a binary search tree is, think of a version of that that's perverted into a way of making log n searches and inserts, which is much better, but it makes your brain cry to try and figure it out. Like I said, I'm interested in these online education aspects, but from me personally, the teaching aspects have been something I've had to learn and had to work at so that I can then do the research. Oh, I realized I never explained what the rocket is. That's an ISIS rocket. I found it work. And so I posted that on Twitter. I'm like, I found an ISIS rocket at work. Yeah, I know. People didn't like that. Dark humor. You got to have dark humor sometimes. My focus right now has been on how do you make programming assignments that you can evaluate. So if you've never made an assignment, then you might not realize that you first have to make the assignment in knowing, at least a complex assignment, you have to make a proof of concept first. Be like, here's a proof of concept, I know it works, you can do it, here's how it would look, and just like the UI. And then you would then, a lot of the times we will take that, make sure it's coded well, and at least for an in-course assignment, make sure it works, take out the important parts of the assignment, and hand out what we call a skeleton assignment. So here's the skeleton of the assignment, you fill in all the sections that need filled in. And you can make that as complex or as simple as you want based on how much of the code you give them versus how much of, here's a main, make it work. So when you're working at a large scale scenario like I'm looking at, you have to then consider how do you make assignments that you can auto grade, because there's no way I'm going to be able to personally grade thousands of assignments. It's just there's not enough time in the day. And so you have to then take these concepts that you might have seen if you looked at the agile development or the talk that was earlier today, or you see some of these concepts in software engineering courses that you take at university or you read online. Test-driven development. You make your test and then you make your software or whatnot. But in making an assignment, you make the proof of concept, then you write the tests for it, then, which is why I call it reverse test-driven. And then you make sure that the tests are really, really good. And this is where a lot of realistic happens in a lot of companies are, we make our product, we make the unit tests, we make sure everything passes, then we iterate to the next step, you make changes. But in this scenario I'm not iterating, I'm then taking the important code segments out and then giving the tests and the skeleton to the students. So they can run the tests on themselves, on their local machine, and be like, oh, why doesn't it work? Well, have my tests give them a good answer, a good indicator of why that's important. So I lean more towards the software engineering side of hacking. I don't know or do we have people, programmers, coders, things like that in this area, or we have more of like networking, or anybody want to volunteer?
Yeah, I'm just an introductory in computer programming,
Okay.
C# this semester, and it's like you said, those boot camps.
Well, I mean, the boot camps, I think, will only work for a small segment of society. If you can devote yourself to doing nothing 24/7, but eat, sleep, breathe, and learn coding, possibly. You might be able to, at least in 16 weeks, because that's a full semester. You can learn a lot in a semester,
Right.
but in a normal tradition of, here's an anecdote, here's a perfect example. One of my professors at my undergraduate, he had a son who wanted to become a doctor, but he didn't realize that until his third year of undergraduate. So he had basically majored in beer the first 2 years. So what he decided to do was take 50 credit hours in a quarter. He got an A in every class. Then they changed university requirements. You cannot take more than 21 credit hours. But what happened was he strategically took classes that were able to, physically he could line up. And all he did was take classes Monday through Friday, like from 9 to 7 at night, and then do nothing for his entire semester but take courses. And if you can focus that degree on learning programming or learning something, maybe you can work on, maybe the boot camps will work for you. I don't think I would learn much from a boot camp. That's just me personally. If you've learned, great. I'm not dogging anybody who's taken it and learned a lot, but I just don't think it, especially for the amount of money that's involved, a lot of them are $10,000, $20,000, and that's what college will cost, or used to. Who knows now? Where's my kidney? So when I'm writing these unit tests, I'm learning from the software side of hacking so I first have to consider, how can somebody hack my tests? Can they reverse engineer the answer out of my test? Okay, well, I got to make sure that my test is non-reverse engineerable. And so you're going to see these mini segments of knowledge that you're going to learn in hacking, and whether it be software or whatever, and you're going to apply them in individual little slots while you're doing your academic or your research work. And so that's where I think there's a strong connection, like, of research and hacking and academics that combine really tight together. But it's not this. So that's more like this, where they tightly couple together, instead of like this, where there's just these two huge segments. You're not going to have a super hacker like from Mr. Robot come in and work with an academic and then they work great. You're going to have somebody with some experience that does a lot of academic work, a lot of research work, and every so often they peg in these, I remember there was this buffer overflow attack that I read about. I'll protect my thing against that. Or how can I leverage that buffer overflow to gain, to rootkit this or reverse engineer this malware? So Stuxnet or Maria, or whatever what's the new botnet, IoT botnet, Mariah. So if you can learn these it's basically, teaching techniques, not necessarily what goal they're towards. And so I'm writing these unit tests and integration tests, and then how do you make peer evaluation that's good? And so you got to consider all of these academic concepts, combine them with a little bit of social engineering, a little bit of making sure people aren't hacking you, but making sure that your code still works. And we're running Docker, so what are the new attacks on Docker? How can I prevent those type of attacks on my auto-graded system? How can I learn? So one of the papers I published was basically a task manager for Docker. So in the simplest terms, we ran, it was a system that would run Docker programs for the simulated project. The simulated program running inside was a calculation of the heat inside a building to control the HVAC. So you have a room, the temperature range in this room should be A to B, temperature room in this room should be C to B, or C to D. And so you have these fluctuations, and you have a physics simulation running saying, okay, great. All this different nonsense of all the physics calculations. I couldn't tell you what those do at all. I have no idea what the calculations are doing inside the simulation. That was a partner of mine. There was 12 of us on that research project, something like that, maybe 8. And we all did different parts. And so we had somebody with the algorithm, we had somebody with the simulation. I helped with the task management because I did a lot of operating systems course in undergraduate, and the Docker stuff. And so you have these segments of groups of people all working together to build this much bigger research project. And so I'm assuming if you've ever done working on a hacking project, you're like, oh, it'd be great if I knew somebody who did software-defined radios, and then you reach out and contact them, or whatever the case may be. So it's the same thing. And so that's how we were able to build the tool that I'm hoping to use in future research of combining that task manager with the auto-graded programs I have to build a deployable open source framework for auto-grading of assignments. Because how do you solve a math question? How do you answer a math question on a course online? Well, you just write in what the answer should be. How do you do a physics problem? How do you do an engineering problem? There are a lot of them, they're just math problems. You put in and plug in the answer, multiple choice. Programming assignments don't work that way. They're inherently much more difficult to answer. So that's why you need the actual do these types of tests, and you run them unit tests or integration tests where you emulate the Android device. I'm focusing on Android just because that's what we're teaching on, but I want to be able to scale this out to other scenarios and things like that. So this is just the second part. I was just going to talk about some of the life experiences I had in the past, coming along and being able to reapply them in academics in a way I never expected to ever use. So that was a desk of mine, the desk at my house, where I have an audio board, a mic on a boom, studio boom, digital converter. There's also a CD mixer in there. I was just using a CD player. But I was previously taught in high school how to do concert lighting and audio. So I used that tidbit of information to be able to set up a studio in my apartment to record the online courses. And so the audio quality of what I'm producing is much, much higher than I would be able to use otherwise. And so the nice thing, I went overboard and bought really nice stuff just because I know I can resell this in Nashville for no problem if I need. But I happen to know what was good and would be able to be resold. But if anybody's interested in That's a side note. If anybody's interested in setting up audio recording for podcasts or videos or whatever, let me know. I can show you and tell you how to do that too. Something else. If anybody has any questions, comments, donations for a grad student, willing to let them out. No questions? Okay, well then I'll be here if you want to come up individually and ask questions or get peppered with mints or just get a few mints. You're welcome.